Hey Krishna, Corey, hey India Mara, how's it going? Good to see you there. Didn't know if you'd be around. How you feeling today? Okay, I'll just need to finish cleaning up my workbench a little bit. Okay, that's that. Get this out there. Hey Baz Cola, Kyle, Wantamak, Ian Robertson. Alright, well, we'll jump into it so it doesn't take too long. Which is, of course, meaning we're going to probably end up with another 2 or 3 hour stream. Basically, one of the things that often happens with the open broadcaster, well, it shouldn't often happen. So in open broadcaster, you have multiple scenes. Like you've seen me switch between them. Like we've got this one of me in the big face. You've got the overhead desktop one. You've got the microscope one, and things like that. Sometimes it's more convenient to just be able to switch a scene with just like pointing to the camera that you want or something like that. So that would be nice. But previously I had one of these units which I made up. It's just a simple what is it for? Yeah, 6-way switch. So let me pick the different scenes. All that would happen is that the microcontroller connected up to the USB, it would generate a keyboard combo, so it's the same as pressing a keyboard combo. OBS would react to that and change the scene. So it was, and I'd have that mounted on the front of the desk or something like that. But often what would happen is when I was using it, I'd forget which scene, which scene related to which button, and I'd end up making a bit of a mess of things. So I put that aside and I've generated the auto switcher for the microscope, which is compass based, and that kind of solved a lot of my issues. But there are still times where I want to be able to just point at a camera and like a boom like that, and it'll come up. So I found these capacitive sensors, and what they do is they just pick up your finger or something approaching, and they effectively are like a switch. I could put a bunch of these switches just on little mount assemblies and cables. That could work as well if I wanted to, but just having a touch would be nice so that you don't have to impart any pressure, because every time you put pressure onto something, you push it out of position slightly. Not that it really matters. I mean, let's be real here, I'm not doing professional video work here by any stretch of the imagination. I could probably run potato cam quality here and no one would notice the difference. Anyway, so we're going to have a shot of using these, and I'm going to use them in place of the switches. Now, the first thing that I found that was wrong is that these switches rely on what we call a internal pull-up on the microcontroller. The reason why we have internal pull-ups on the microcontroller input pins is so that you don't have to put an extra resistor or run an extra line out to the switch. So by having an internal pull-up on the microcontroller, it has a resistor inside that it switches on, and that yanks the line, the sense line, up to whatever the voltage rail is, 3.3 or 5 volts. And then all your switch has to do is just short that line to ground. And because that's already got a resistor in there, it's usually around about 10k in these microcontrollers, you're not going to get a short circuit as such. It's just going to drag the line down to ground, which registers as a 0, and then your software can go, okay, we've gone to 0, the button's been pressed, and then you wait till it comes back up, and it's a complete switch. So having the internal pull-ups saves you a bit of space on the board and a bit of routing, but it's an inconvenience at times, because when you get devices like this in particular has an active drive on the signal line. So what it's doing is it will actually push 5 volts out on the line when the button, when your finger comes near it, and that conflicts with the fact that we've got an internal pull-up. So what I have to do is rewrite the software for this to handle the fact that this is an active drive. Now, why it's become a little more complicated is because I have lost the software for this. I've lost the firmware that I wrote, so I'm going to have to start from scratch using an existing project that I originally started with from the internet, and hopefully I can remember what I'm doing. Anyway, so that's the gist of it. We'll see what we can do. Hey, Braden Smith from Louisiana, 2 a.m. It's a little late. India Mars, you trying to play your ukulele? That's different. Hey, Margarita, Accuse, Lexi, voice command sound. Voice command, yeah, that could work. It could also get rather inconvenient at times. These are basically the same boards. This one here I was looking for originally. This is the second build that I made. It basically just has cherry blue switches on it rather than these ones here, which are, I don't know what they are, but there's no tactile feel in them. And I've wired in already the cable to the contact points there. So theoretically, I can just sort of connect that up. I'll have to take the switch off and the LED actually no, we'll leave the LED in there. And then I have to reflash it. Reflashing it's going to be the fun thing, because I have to find all the equipment for the flashing. Zaki, yeah, this here is kind of like an Allegro Stream Deck, except it's a very archaic type looking version. It doesn't have any prettiness about it, but because of the way the switches are done electrically, it's not compatible with me just simply wiring one of these in as an alternate switch. So I have to physically remove the switch and then reprogram the chip so that it understands how to handle an active drive type line. Essentially, I've just got to disable the pull-up on that particular trace. And this here is the hodgepodge schematic, and I'm pretty sure that there is switch 4. So that's on there. And anyway, that's like I said, I have to do it in software, and hopefully it will work. I guess the nice thing about the Stream Deck is the fact that it had the nice pretty pictures on it, and the fact that it can be dynamically changed. So like as you press one switch, it can dynamically change the others. And I see now that there is better Linux support for it as well. We get that first switch out. Sarah, no, that's not the problem. The problem is that this will... The problem is that when you have an active pull-up, your line is effectively high the whole time. Whereas this actively drives the line when it's been pressed. So it's a conflict of the signaling styles. The capacitive thing can do, it can pull down that 10K no problem, but the trouble is, because it wants to drive the line, it causes a conflict. It's probably a case of it probably doesn't actively pull it to ground. It just simply rests at open line or something like that. I don't know exactly. Yeah. All I know is it's not working properly. I do have to take the damn LEDs out. Don't you dare mention Arduino. This is not Arduino, this is AVR. I never for the life of me ever supported Arduino. Yes, it is very much like a button. Dear God, I'm going to start kicking people off soon. I mean, yeah, you could use a physical button, but like I said, I don't want to have to be actually pressing in buttons. It's nice when you can just hover next to something without physically touching it and achieve the same result. But yeah, I mean, I could just like take this switch right now, run wires straight up to the side of the camera next to me, and voila, we're done. That's not the purpose of this. The purpose is to try and use the capacitive input. Some people seem to find it a very difficult concept when you don't do it the way that they think that it should be done. It's like, oh my god, you're not doing it the right way, why do it that way? So just run off. I'm gonna try something different, doing something different. Screw the lot of you. Honestly, in my life, I get so many events where people have like said, no, what are you doing that for? You just start to become actually quite hostile towards that sort of mentality. It's like, well, just go jump off a cliff. Thankfully, I don't listen to them, but I will yell at them. The A word? What A word? What did I say? Oh, the Arduino, yeah. It's not so much that there's a rivalry between AVR and Arduino. It's rather just the case that the Arduino is a sort of convenient macro. It's a convenience layer on top of what was originally the AVR system. And with the AVRs, you just code them in plain C, and it was perfectly good. Particularly when you came from the days of PICs, and everything was done in assembly, and then all of a sudden we had the convenience of a meaningful, useful C-based system that worked. And then Arduino came along, and it was fine, but then everyone started thinking, oh, everything like this is an Arduino. It's like, no, it's not. Some of us actually do program it still originally in C, like it was intended in the first place. And I think perhaps some of that hostility is more a case of the fact that it was never that hard in C anyway, but someone decided they wanted to create some macros to make it a little easier to press, detect a button press or whatever. Yeah. Maybe you can find parallels in the concept of the fact that I'm going through all this trouble just so I can use a capacitive sensor when I can use a switch button anyway. There you go, there's your parallel. Ah, g'day Wayne. Anyway, this is strictly going to be test. I'll have to respin this board if I want to do it properly. I mentioned how I do not like pin-through jobs. Surface mount is just so much easier. Yeah, well, again, Tom George, I mean, that was the AVR. I mean, AVR Atmel bought out the simple ISP. So that's not Arduino that did it. It was just Atmel. I mean, you can get the 3 resistor parallel port programmer and you're done. It was just beautiful. So when you were used to years of trying to do everything on PIC and you had to pay big money to get the programmer, and then Atmel comes out with the AVR and you need 3 resistors and a parallel port, I was like, are you kidding? That's just way too easy. And then the software is free. And the performance is better even though the frequency was substantially less. Yeah, Atmel really did make a substantial change to the market. Of course, then Microchip won out because of the fact they just went along and bought Atmel. Well, about 10, 12 years ago, everybody had a parallel port still. Oh god, Emery still. Do you want me to throw you out? Non-physical pressure buttons can be useful in scenarios where you've got a whole bunch of gear set up on the wall like I do, and you don't want to have to go and actually push stuff to make it work. You just want to glide your finger past it and switch. Oh man, it seems like this event's turning out to be worse than me programming. Jesus. Oops, sorry to all those who are religious. This is why, a lot of people have complained to me that I don't talk a lot about what I'm doing when I do projects, and this is why. It's because you waste so much time explaining to people things that really maybe if they sit back and just watch instead. No. I know, I'm sounding hostile. Alright. Not so much dumb crowd. It's just more on the back of everything else. I'm starting to get starting to get the hairs on the back up. Okay. Well, we can't have that actively powered yet. Partly because the control line is part of the programming interface. Just due to the way that the routing was done, it ended up that way. It's like we have the programming interface here, and some of the lines are shared. In this one particular, SW4 is the MOSI line, so we can't have that actively connected while we're doing the programming. It's not a problem. Anyway, now I've got to get a programmer and hope that it works. I think I'm going to disconnect my barcode scanner for this one. Not that it's a problem. Okay, let's see, that's one programmer. Yeah, this is the one I want, I think. And then I need my adapter cable. It's SPI programmer, adapter cable. Hey Jim, how's it going? I possibly could have even made this system using this type of board. They're all based on the UDEV, USB VDEV, VUSB. Anyway, that's a software-based USB project. Okay, so that's working. So that's fine. Damn it. Wayne, did you send me those nozzles, by the way, Wayne? These ones? All of these? They kind of look like the sort of thing you sent me. I can't remember. Hey, Miriam. Okay, now the fun part, the software. Are those sensors TP223s? I'm not sure actually. You'll know it's got a SOT236 on it. And my switcher is not running. Okay, that's working. Looks like these ones are... There's 223. Even got LED on it. I wonder if I could... It's a shame I can't drive the LED from the line. Toggle it or something. Anyway. Right, I was wondering that, Wayne, because I knew that you knew, and I was like, okay, what's Wayne doing sending me oblique nozzles for? Well, that explains everything. It's gonna go. Alrighty. Okay, so this is the original project that it's all based off, which is the HRD keyboard thingamajig. It's always a bit awkward trying to program with this keyboard, but anyway, we'll see how we go. Let's see. These people here, this objective development, I don't know if they're still actually a business or anything, but they did a superb job of making life so much better for everybody with AVRs and their USB interface. Let's see. Just trying to... Okay, so I've got right now, it should be Control F10, hopefully should be issued when I put my finger onto that, in theory. But the more important thing here was that I turned off, where is it, hardware in it? So I've turned off PB3, but I'm pretty sure that's the one I want. Yeah, it's PB3. So it's got no pull-up, so it's just going to read whatever this device is generating. Jim, it's actually not even that. It's more a case of many a time when you're running around trying to switch between scenes and things like that, it's often easier to simply just point your finger at whatever device it is you want to switch to. High on sensing, low on idle. Yeah, that's right. So which actually reminds me I need to test that that is in fact the opposing. Well, high on... Yeah, that's right. So it'll be the opposite of the normal. So I'm going to have to explicitly detect PB3. Right, that is not what I asked for. God, I hate that programming style. Okay. So we're going to actually make it a little less than ideal. Maybe we can just cheat for the moment. Going to blocks out the PV3. We'll explicitly just test for it here. Dun, dun, dun. If pin B 3 is this I+1. Take PV3. Ooh. And does have a pin to select it, really? Okay. Unfortunately, because this is already preset, I'm just going to go with what it's easy for me to do it in software anyway. Let's see if this builds. Yeah, small issue. Okay, looks like I'm gonna have to. This is why it was a pain originally when I had to do this, because everything in here has got to change. Because this uses an old programmer. I'm using AVR dude. AVR dude. I'm gonna have to bring up another window. Let's see, development project. Trying to find a suitable project for me to get this off. PGMSO3. Nope, that's the wrong one. I'll probably do. Hey Liam, how's it going? I don't know if this is going to help or hurt people trying to do anything similar. This is me just going about my stuff. Okay. Yeah, not even going to bother. Okay, compiling works. That's all that matters there. Compile, compile, compile. Okay, flashing. AVR dude. Nope, not even happy with my old code. I'm genuinely having a hard time trying to remember the last Mega 88 project that I built was. From scratch, that is. So I'm pretty sure these are 88s. I mean, an 8 or an 88, it really... Oh, these are 48s. Same thing, basically. The reason why all this has to be changed is because all the commands here are meant for the UISP programming software, whereas the AVR dude's entirely different. SP was the AVR 80 mega 48. C USB what? I think it's AVR ISP2. I can't remember. Now it looks like I have to set the fuses on this too. So H fuse. Except these are Mega 8 fuses. Okay, since it's already programmed to work, I don't think I'll... Wherever my last bit of source code is, it obviously flashed it to the right fuse types. So I'm not going to mess with that. We'll just push the hex file onto it. That might work. Okay. Now, in truly marvelous technical perfection way, I don't even use a proper connector. I just have a programming port in the board, put in my 0.125mm pitch in there, and hope. Make flash. You broke me. What did I break? Oh, I know. Maybe that. Flash. Sudo. Try that. That's what happens when you get out of these projects for long enough. Let's see. Grep minus IR mega 48 star. Just a couple there. reflow oven. Yeah, that's a far more functional line here that I can use. No. Yeah, this is a lot of what programming and fiddling around is. Finding the old bits that you did used to work and doing it again. It's only difficult because I'm morphing someone else's old project using an old okay, what do I want? Minus E minus V. Okay, that's right. Mega 48. Ah, it's USB tiny. That's what it was. I forgot about that. There we go. Programming. Yeah, Stray 77 was a USB tiny. I used to have some AVR SP2s, but I've since replaced them with the USB tinies. And that's done. That's flashed. And now, as long as I don't lose this project again, it might actually work in future. Okay. So that's ground. Plug this in. We have a light on there. Device not enumerating. Come on, don't be like that. Disconnect. Unable to enumerate. Yeah, it's pretty weird. Don't normally have this trouble with these switching boards. You probably wants the computer to be just restart. Let's try something else. No. Alright, that's weird. Okay, we'll try it with that disconnected, just in case that's influencing it somehow. No, have I got a fault on that? Let's try this one. Well, that one worked just fine. Okay, time to check the board. I mean, it flashed fine. Actually, should probably put that wire onto the input. Maybe not. Because I think if the chip's running at obviously 3 volts or 3.3, so probably shouldn't power the touch button if at a higher voltage. This is the other one. Alright, we'll flash the other one. Let's see if I can bring up the programming window. It's probably a bit like watching some people do things like fix their Bafang bike. Okay. Okay, it's done. It's a USB Tiny. Okay, it looks like it's something wrong with the code. Bugger. That sucks. And of course, like a moron, I didn't take the code off that. I didn't take a read copy of it. Alrighty. Crap. Time to get serious. Bring the keyboard out. Yo, gross. Not much better. Is this programming with the wrong chip? It is. That's why. There we go. And now we get to the fun part. Like, as I was saying, there's the Mega 8 and the Mega 48. They are very similar chips. In fact, usually you can move up to the 48 and the 88 no problem. But there are a few things that have to be renamed. So we do have like TCR, TCCRO and TIFR. They've been changed in the Mega 88. And now I have to go and get the data sheet for the Mega 88 so that I can remember which one's which and what I need. Atmel 80 mega 48 PA datasheet. It saddens me that Microchip ended up buying Atmel. I knew it was going to happen, but it still saddens me. Actually, just give me a second here. A floating head. Damn it, my mouse is not on a mouse pad. No, no, dear God, no. Let's try that again, shall we? Nope. Paul's just... You mangy little things. There we go. That'll do. Alright, that was a lot of drama for nothing. Okay, so the first thing I'm going to worry about is this TCCR 0, so it's a timer prescaler. Let's see, TCCR, it'll be 0A or 0B, I guess. 0. TIFR 0. Okay, so this one down here is going to have to be changed to TFIR 0. So main C, and we want line 277. 0, 0, whoops. Alright, that's that done. And TCCR 0, that's going to be an A or a B added into that. Zero B. I don't know whether it's going to be 0A or B. Well, guess we'll try both. 65. It might work. Boom, boom, boom. It's not that Microchip is bad per se, it's just that they already had the pick, and so it was kind of like, you know, AVR and Microchip were competing for the entry-level Microchip type scenarios, and there was always concern that if they decided to buy Atmel out, they would sort of find a way to cannibalize the AVR or kill it off in a way. Just slowly lead it to its death. Fortunately, at least, things like the Mega 8 and the 88, or the 88, the 48 series, they're going to be around for a long time. And they're a good money spinner. And they're a good chip. What's this? What are you complaining about now? Nah, just need to be held down a bit more. Okay. Yeah, let's see what happens now. Still no good. Oh wait, no, yeah, it's come up. Okay. Yeah, we got it. Let's see if any of the keys work. Not getting any key activity. nothing happening. When the pics first came out, I was interested in them, but then I saw they just, they didn't quite appeal to me enough. But when the AVRs came out, it was like, yep, that's what I'm going to go for. Yeah, nothing is coming across in terms of events on this. So I don't think our code's quite fixed yet. I may have to steal code from somewhere else. Oops, wrong. Surely I didn't go through all this work before. It just doesn't seem like I would have. I only wish I knew what I did with the existing project that I, built those with. Make flash. Starting to think I need to just Google for a version that's already been adapted to the Mega 88 or the 48. I just realized this is not even actually running, because what should be happening... Yeah, let's see, get this out of the way. Overhead. Let's see. Okay, what should be happening is these should be lighting up. So something's not running right on the chip still. Robert, if I'd missed one of them, then it wouldn't have compiled. Alright, what am I missing? So we know it's not that. Ooh, Ball and Pascal. Now that's some nice coding. I like Ball and Pascal. It's a little bit wordy, particularly once you get used to C, but it's still nice. Oh, I know why it's not doing the button thing that I'm expecting, because I wrote that into the code that I modified. Alright, what I'm going to do is I'm actually going to search my system to see if I can find anything that's similar in code. So like if I look for something like USB HID report descriptor or something like that, or even actually key pressed, that might be enough. Or pin assignments. Surely I've got to have the code around here somewhere. Yeah, Delphi definitely killed Pascal. I mean, Delphi brought about a whole bunch of new things for people to, new type of people into programming, but it killed off the existing ones. No, that's my own code being listed there, different reasons. Crazy, it's not even in there. Let's try my other machine, the machine I actually have downstairs. No, I don't want to limit it to just C. I just want to cover everything. Nothing in that. Nothing in there should actually... That's what's got me stumped, is the code should not have vanished. I think it might have been a case of it was on a hard drive and well, normally all the code is backed up. Like this Atmel folder that I've got, it exists on 4 different machines right now. But this could have been a one-off project that I just, for some reason, I don't know what I've done. Yeah, maybe it is self-destructing code. Damn. Where are you, little code? Nope. Nope. I have a view. It'd be very unlikely that it's on my workstation machine. Very unlikely. Fuck me. I love when people tell me stuff. I've been using Git now for many years, and yes, I'm well aware of it, but this was done before any of that, and I hadn't Gitted this one, but everything else I get. Thank you for telling me what I know. But thank you. I'm in a cranky mood. Everyone's going, oh, let's unsubscribe from this bastard. He's getting all cranky. He's got his cranky pants on. Go have a look at my Git page. There's like 40 plus projects on there of mine. Is the port name the same for the new chip? Yes, the port names are all the same. They are consistent. Yeah, Defcom, you'll get a fiery death. I'm just pressing LS all the time. That's when you know your brain's burning up. Where the hell did I put this thing? Mac Mini? Nope. Nope. Genuinely gonna have to resign myself to okay, let's see if I can find it. Let's see, 18 mega, 88, USB, HID, keyboard. If I can find one that's based on the Mega 88, I can change it down to the 48, and that won't be a problem. Someone's got to have already done it. Damn it, so this is the same thing as what we've already got. That's for the Mega 8. In fact, this looks like just a copy of the existing one, yeah. It's a 48, not a 88, no, so I'm pretty sure. It wouldn't have let me program it if it was mismatched. Yeah, it's a 48. Yeah, they're both 48s. Like I said, it wouldn't have let me program it if it was a mismatch of signature. Okay, someone's done it for a 328. Hey, Fred MIDI. Okay. They're using a different... Okay, it's going to be just as much drama modifying their code because they've got a very different setup still. So... And these pictures are not very good. 2313, Mega 8. Like I said, clearly I must have done it sometime in the past. Mega 8. I love it when you search for Mega 88 and it still gives you Mega 8. Okay, Q's, have a good one. So now this is the original code that I've got here right now, but like I said, it's for 8, not an 88. Maybe we're going to have to go through and do it the manual, hard, painful way. Oh, what is this crap? Yeah, sometimes I just say it is the only way forward. Alright. What we're going to have to do is have a look at the fundamental differences between the 8 and the 88 in terms of clock configurations, dividers, things like that. At least we didn't change our fuse settings. That's a good thing. Okay. Now I need that. That font is just too big. So the USB setup side is okay. We're just not reporting any keys. Well, I guess at this point what we do is we start going into the debug mode and start making LEDs blink. Program read word. Okay, that's doc 2554 PDF. That'll be a migration doc, yep. That looks like a migration just between the actual, all the chips within the same series, so that's, you know, 4, 8, 8, 8, 16, 8, not between 8 and then to the next series. DEFCON, it basically shouldn't matter because I have used these before, and yeah, they just issue. You will see it come up in the terminal window. And also when I was running XEV, which is an event sense program, so basically whenever you run XEV, anything that happens as an event will show up in there, and nothing at all was showing up. So, fed to MIDI, this is C code. Ordinary, good, wholesome C. Okay. Not Arduino, not C++, wholesome C. Now I'm just bringing up the Mega 8 now in another window. What doesn't help is that I actually find it very awkward to program on this workbench. If anything, I should be down in the other side. Oh right, yeah, no, it's just not sending anything at all. Let's see. Okay, everything on USB side. Nah, it wouldn't be connecting up and reporting properly if I had anything configured wrong with the USB side. So it's more the event issuing. Cat video, not happening. Not today, not today. Last key does not equal key, last key equals key, did key change, 1. What was... Ugh. I hate it when this is done. I understand why they've done it because it's associated with the keyboard function, but I hate it when the defines, the hash defines, aren't all up at the top of the code. Because if you're neck deep in code and you look at this and you kind of go, oh, I'm at the hash defines, I'm at the top of the code, there's no more functions above me, but there is. Anyway, it was just throwing me for a second there. Oh, and this freaking... Get out of here. Keyboard's rocking on something. Driving me mad. Thank you. Like this function here, this key pressed function that we need to look at, it's I guess everyone's got their style of doing code. Alright, first mistake here. I was doing a I wasn't doing a bitwise AND, I was doing a logical AND. Not that that should have caused it, but it might. Anyway, what cap lock's on? That's what you get for raging, Paul. Not even the right folder still. Alright, so it builds at least. Probably should have 2 USB cables for this, but I'm too lazy. Given that I didn't press any keys, the fact that that just maximized my window gives me hope that, yeah, we got something happening here. We have a... that is indeed reporting now. Let's plug in the touchpad. And it works. Except that it likes to kind of... It's rather sensitive, in fact. Okay, we're going to go with the all-in. It's very sensitive. This may get thrown out the window yet. It's definitely responding, but it has a bad habit of running off. Okay, so we've made progress. We are actually getting our events reported now. You mean transition detect rising edge or trailing falling edge? Yeah, here we go. More people telling me what to do. Anyway, this is the joy of doing development, is, you know, when you're trying to fix up something like that. I mean, yeah, there are nuances that you have to deal with afterwards. But the first thing you got to do is actually prove that you're getting some communication. Then you go, okay, now let's look at the next fault, and you move to that. And then you go, oh, there's a little bit of an issue there. You move to that. As opposed to, bam, it's perfect first time. Except this is why people like me hide in caves, because we get a little bit cranky. Ice cream would be nice. Key pressed. Alright. What doesn't help is I don't actually know the logic behavior of this particular device. I haven't looked at its data sheet. Oh, I remember its data sheet not actually saying much. I'm trying to think whether I should also put 100k to ground or something like that. Pin 4. What? Pin 4. Oops. I don't think it's even a toggle. It's more a case of... yeah, I don't know. Anyway, I'm going to have a look at the data sheet, see what it says first. And nope, yours is different. Have a look at what they've got. Let's see, pin 4 you say. Pin 4 looks like it, where are you being dragged off to, buddy? Looks like you're being pulled to ground by 1K2 resistor. Interesting choice. Pin 6 is toggle mode. Oh. Can you, let me just find, what was the part number on this? Something, what? 223. JL223. TTP, that's right. Okay, so pin 6 we want to ground. And pin 6 is to ground there. I mean, admittedly it's via this 1K2 resistor, but it is still to ground for all intents and purposes. And pin 4 is also to ground, so it's active high and direct mode. So yeah. So it is as would be expected. Now what I could do is replace this 1K2 with something, well, just with a 0 ohm, if people are concerned that the 1K2 has given it too much of a float. But I'd be pretty shocked if it was in float. So what do they have? Capacitor across pin 3 to ground changes sensitivity. Okay, yeah, I see that CS. So it's that one there, so that there. Okay, that makes sense actually. Let's see. 0 to 50 picofarad, I reckon. I'd say we put a 50 picofarad on there, probably a good job. I'd say they're, yeah, with it floating like that, it's going to be picking up, particularly around here. There's a lot of EMF, with things like the hot air station and everything like that. So definitely, I'd say 50 picofarad would be a good start. It looks like it's a 603 size or 402. I don't care. Oh, Eric, I don't like children. 1 microfarad? Nope. I don't have too many picofarad class bags of electronics. AM6 skills, we're looking at the data sheet now, so it's not a problem. It is configured as I would want, but it looks like okay, we've got a 22 picofarad, the 805 chips though. We'll see if we can find something a little bit smaller, 603s. I should have 22 picofarad 603s, come to think of it. I've just got to find them. What do you... 805s. It's got a lot of 805 junk from when I very first started in doing surface mount stuff. Because 805 is about the size that you can easily handle without a microscope or anything. You can just visually pick them up dead easy. Oh, come on, surely I got 22 picofarad. worst case scenario, I'll put 200s in series. 680 picos. Otherwise, I have to steal something from another bag or something. What are you? 4.7. You kidding me? Alright. Okay, we'll just use the 805s. It's a bit large, cumbersome, but it'll be fine. Datasheet recommends MP0. Well, I don't think we'll be getting into that at that level. For now, just having a capacitor is fine. Dunk. Yeah, 805 is a perfect fit actually. Okay, to be fair, it really should be 603, but 805 is close enough. Klingon. Parts so big you can pick them up with your fingertips. That's about 100 times too much flux. That's a bit of a joke. I really don't even use hot air for this. I just soldering iron tip it. If it's still too sensitive, I'll put another one on top, and that will give us 44 picofarad. Okay, finger down. Oh, now nothing works. Oh wait, no, my bad. So yeah, it just runs. I'm almost tempted to put a 10k resistor or something on that cap. Alright. And now it goes crazy. There's my ground. Okay. We're going to put a 10k resistor on the switch input to ground. It's not sticky, it's more just it rapidly floats back up and goes out of control. While it's in the presence of the finger, it moderately behaves and then it goes out of control. So yeah, we'll just stick about a 10k between there and there. It may stop it from misbehaving so much. Might be able to bridge that for 1206. Where are you guys? Caps. No, wrong resistors. Ah, there we go. Now the pull-up would have been inconvenient, unless of course I switched the thing around. Scope's not going to help me, especially because I don't have a scope anymore. $15K will be fine. All the scope's going to do is just show the line drifting up. Probably. Maybe. Hopefully. So I just realised that what I thought were 1K2 resistors probably won't be. I forgot that these things have their own little codes. They're not actually numerical. Not until they get to about the 805 or 1206 size. Am I disconnected? I'm disconnected. Okay. Pull-up would have been counterproductive for this because it would have been pulling up. But yeah, we would have had to turn that chip around the other way around. Aha, 1 BC, I get it. I wasn't sure what you were saying there for a second, but yeah, I got it. There's also an unfortunate hair on there. Oh wow, and it drifts off again. Wow, you're really annoying. Yeah, it could be a grounding issue, could be... Have a look at that schematic again. Pretty damn simple circuit, really. Interesting in their schematic that That's just weird. It's interesting how the option lines, the TOG and AHLB 4 and 6, they talk about putting them to ground or running them to ground or pulling them high. But on the schematic, it actually, you can only tie them high. It doesn't actually let you, well, they are saying not to tie them to ground directly. It's toggled for direct output. It's for direct output. We went over that before. Direct output, output high on press. Ni hao, Victola. I actually did my 5 seconds of Chinese today. I remembered how to say Zai Xian. But I'm not saying that yet. I haven't finished. But yeah, so like, this is what I'm talking about. Is okay, up here. Where is it? Okay, see, they've got 0 default mode is direct, 0 active high. So that implies that, you know, you're going to tie them to ground. But when you look at their suggested schematic, they've got this switch option here. And so really they should be saying leave floating or tie high, as opposed to tie to ground or tie to high. You gotta love the ambiguousness of it. Probably have internal pull downs, possibly. That's why it's nice to have sometimes a data sheet that shows you at least a example or a simplified version of what they have got in there physically. It'd be unusual to tie it low internally. If anything, you'd normally expect a pull, a tied high or pulled high internally. The whole MPO capacitor thing is just so that as your temperature changes through the day, the response to the finger doesn't change too much. So I guess the question is, do we have a crappy... That said, this, when disconnected, creates a lot of... Like if I plug this in, and it's disconnected, it still generates crap once it gets started. Come on, do it. Do it, do it, do it, do it. Come on, I dare you. Do it, do it, do it. Damn you. I'm pressing it, it's not doing it. Hey Adam. Data says CMOS input and pull low resistor. Oh, does it? I didn't see the pull low bit. So it gets connected now, nothing's happening. I touch it, and then it's on. It's off to the races. If I disconnect it, it continues on. Let me short... I'm going to short the signal line to the ground. Signal line to ground short does not function. Interesting. Okay, some sort of software issue. Or combination issue. I can change that to a edge detect. But things have to be done a little bit differently like that. That's fine. Alright, let's try edge detect, and we're only going to look at that one pin, so we'll actually mask out everything else. And I gotta remember, and you actually do it through interrupts, which could be a problem if it's affecting the USB code. Is the code toggling states in the microprocessor? No, it's not. Because basically it's just reading the input of port B, seeing if PB3 is high, and if it is, it returns 4. It's that simple. And nothing else. What I find interesting is that technically it shouldn't be repeating all the time, because there's a bit of code down here that should technically stop that. This here. So I don't know why that isn't doing its job. Okay. There is another way I can do this though. Let's see, FMB. Yeah, we're going to do this a slightly different way. I'm going to tell you to shut it soon, because that's exactly what I'm doing. Kind of. I'm actually making it a 3-state interface. Not quite. Yeah, too many cooks in the chicken. Too many cooks in the chicken? That's really a bad state to be in. Yeah, Tom George, the trouble is, to do leading edge detect, I have to do it through the interrupt system, and to do that may interfere with the USB timing sequences. So that's why I'm not doing it through edge detect. I can do it, but it will probably mess up the USB sequence. So we're basically having to do something similar, but it has to be through software. Well, I'm wondering though why it's even having this issue in the first place. You know, we've got a pull down resistor there and everything, and it's still somehow managing to pull up. Or drift up, rather. Sorry, this is called on-the-fly coding. No. Wrong side. Right, okay, if A3 Deacon. One thing I hate about this sort of coding is that you got to use volatiles. Char. Okay, I see what you're saying, Defum, like it takes a while for it to actually come back off. But that doesn't explain why it was misbehaving as soon as after I disconnect it. That's the other thing. Particularly too that I got the discharge resistor on that pin line. That's the thing that's really throwing me. Unless, of course, I've got my... Have I got my hardware in it? I'm just going to disable all of them. So there'll be absolutely no pull-ups. Let's see, warnings, warnings, warnings. No one cares about warnings. Okay, it's transition. Touch sensor. Okay, press it. Looks like we fixed it. Yep, gotcha. Now it's behaving as it should. Fixed and working perfect. Let go of it. Yep, as soon as I touch it, it's good. I shouldn't have to touch it much though, just... It's like Harry Potter, I can touch you now. It works. Fixed. Now the question is, we'll go back and find out, was it my pull-up code or was it something else? Now I'm fairly sure that port B and equals invert 1 PB3 should set that back to 0. We'll see. Blimey, heck. Talk about a heck of a lot of cranky arguing over that. Okay. Okay, plugged in. Okay, so that code's fine. Yep, nothing wrong with that. So it must have, for whatever reason, it was not happy with the way the state evaluation was being done, and by us putting it through the 3-state system, it was good. Yeah, let's try the other buttons, see if they do anything. Oh, they won't, because they're knocked out of the evaluation. So no, that actually should be 2. So what I'm doing here at the moment is re-enabling all the functions, pardon me, re-enabling all the functions we disabled in our pursuit of the problem. Okay. Ooh. Okay, the rest of the code has some problem going on in it. I'm probably doing something a bit wrong there. I guess really this is all kind of pointless because I really only want, I've got 4 of these touch sensors, so I'll just replace all the rest of them. Something in that code needs to be improved overall with regards to the key state detection. Right, we've got it backwards. Did I just blow up my thingamajig again? I think I did. I did, yep. Nothing like putting 5 volts on the wrong way. Yeah, they are the 223s. Yep. Okay, let's confirm we haven't lost any functionality, which so often happens when you enable something and then go, oops, that's wrong, and then disable it, and you find you've lost your functionality for some reason. Okay, now we have the button. Alright, now the next trick is tying this into OBS itself, and this is going to create one of those marvelous effects. So say if we want to make it so it switches to the infrared. So we go settings, hotkeys, switch to scene, there we go, apply, okay. Overhead. Alright, so when I press this button it should switch to the infrared scene. And it does. Marvellous. It works. And that is a long way of going about just replacing a goddamn little button. Oh, blimey heck. Ow! Why did I crack my fingers? I don't do that anymore. It's such a childish behaviour. So yeah, I've got all these, and I'll have to add the capacitor to each of these. So I might as well do that now. Ah, I touched it. Disconnect that. .3D printer case. I was going to use double-sided tape. Put my glasses on. First thing I'll do is get rid of the dodgy solder. It's crazy to think I used to assemble boards with 603 and 402 parts just like this, just by looking at it directly like this. I don't know how I did it. 805 is definitely my limit now. Hey Robert, yeah, unfortunately. Not that I can clearly see what I'm doing to the degree I used to, but I can go by feel, which still isn't the best way, but it's kind of like parking. You know, sometimes you can just park by feel. When you hear the bang, you know you've backed up enough. Oh. I will have to inspect these under the microscope. Yeah, I don't think I'll be getting a 100k Tesla. God, I wish I could. I really do want a Tesla. Well, it's a little blobby on the end, but that's fine. Just a bit of excess solder. Yeah, it's tolerable. Not bad for blindness. We'll just take that excess off. There we go. Got it. And they're ready to go. Ah. 0206. I'm thinking you're meaning 1206, I'm going to guess. What focal length of the spectacles you were wearing then? They are around about 30 to 40 centimeters. It's explicitly meant for the purpose of this sort of close-up work, like when I'm working on iPhones and things like that. Anything, yeah. Let's see. Yeah, it's about, that's the distance. I don't know if that's in screen. Back it up, back it up, back it up. Yeah. That there's pretty much the perfect distance for me. Yeah. And that's for working on the iPhones and things like that. I can't use them for programming or anything like that. Let's see. Yeah, I got them. I specifically asked the optometrist for them. They took a little bit of getting used to. It was probably about a week before I actually felt comfortable with them. Now that I am, I don't want to not do. I don't want to work without them when it comes to disassembling iPhones and things like that. Particularly useful when I'm trying to get like the tri-wing screwdriver into the heads and things like that. So it made a world of difference with the speed of my screen replacements. Prior to that, I was always just going by feel. Like I'd see that the screwdriver was with the screw, but I couldn't quite align the heads up quite how I want. Anyway, alright, well that's the end of that. That was painful for everybody involved, including me. I will probably have to, I'll probably spin a different board. This is more, this is more getting a proof of concept. So I'll take this board design and I will spin a new version of it. I'll still keep the option for the buttons, but I'll then also have a 3-pin header so that we can connect the fly leads for the touch contacts. Maybe in 2 or 3 weeks time they'll turn up. In the meantime, I will probably, let's see, I'm going to need 1, 2, at least 2 of them. And I'll wire them up in here, and then at least I'll be able to switch on demand when I need to. Let's see, what else we got there? Alright, looks like I've alienated enough people. Everybody's run away, so that's good. Job well done. Okay, Flatlander, I'm out of here, mate, sorry. I'm gone, trying to get some food. It is nearly 7 o'clock, so I'm definitely overdue for dinner. And I will catch you all next time. I've got some machines to repair tonight, but I may or may not come back for that online. Anyway, you all take care. I'll see you later.